Hello everyone, welcome back. In this section, we're going to talk about sets. But what are sets in Python? Sets are collection of unique elements in Python. They are mutable, but their elements must be immutable. Let me illustrate this concept with an example. Here I'm declaring a set. The set has three elements, 1, 2, and 3. So the set itself is mutable, meaning that I can add an element to it or I can remove one element from it. And when I print my set here, the set was originally 1, 2, 3. I added 4, then I removed 2, so the set will have 1, 3, and 4. These three elements. So it shows that the sets are mutable, so they are modifiable, let's say, in other words. However, the elements of our sets must be immutable. What do we mean by that? So a valid set, for example, is like this. We have one element called hello, one element is 1, and we have a tuple to be one element of this set. So a tuple is inside this set. And it is possible. Why? Because we learned in the previous sections that tuples are immutables. So when we are declaring a tuple, we cannot change its element. This is why they are allowed to be part of a set. However, this set would be invalid. Why? Because one element of this set is a list. So a list is inside this set and it is declared to be one element of our set. But we will have a problem with that because lists are modifiable. So they cannot be a part of a set if they are modifiable, because we mentioned that sets themselves are modifiable or they are mutable, but their elements must be immutable. And because here we are having one element as a list, here it will have errors because this element, that a list is now an element of our set, and that element is modifiable. Therefore, there will be a problem. So we cannot integrate lists inside sets. And sets are generally useful for storing and performing operations on unique data. And one of their key features is that they do not allow duplicate elements. Let me illustrate the differences between sets, lists, and tuples that we learned so far. So sets and lists are mutable. So it means that we can add one element or remove one element from them. However, tuples are immutable. It means that they cannot change after they are created. This is why tuples can be one element of a set, but lists, because they are modifiable, cannot be one element of a set. Regarding the duplicates, sets do not allow duplicate values. However, lists and tuples, it's okay for them to have duplicate values as their elements. Regarding the usage, for unique elements, sets are for unique elements and they are fast membership testing and are very good for mathematical set operations. Lists are usually practical for dynamic collections of elements that frequently change, as we learned in previous sections. And for the tuples are very good. These are very good for fixed collections of elements that should not change. And with respect to the syntax to declare them or to create them, if we want to create a set, we need to define them with curly braces or use the set function here, like empty parentheses. To define list, we learned that we are going to use square brackets, and to declare a tuple, we learned that we are going to declare them using parentheses. In the following videos, we are going to talk about different concepts of sets, and we are going to provide a lot of coding exercises so we get familiar in this section with sets in Python. Thank you for watching. Hello everyone, welcome to this video. In today's video, we're going to learn how to create sets and different types of set creation. Here, I'm having my first set being declared using set function. So when I'm having this set function to be assigned to a set variable, it means that I am defining an empty set. So whenever we want to define an empty set, we are going to use the set function. Then I'm having another set being created. It is called numbers, and this set is having 4 elements: 1, 2, 3, and 4. And finally, I'm having my third set being declared here, and it has 3 elements: 1 integer, 1 float, and 1 string. As we see, there is no problem if there are elements of different types, of different data types, let's say. And finally, I'm here printing out these 3 created sets, where I'm showing the message empty set, set of numbers, and mixed data set. And I'm calling their name. So I'm putting the name of my sets, so it is going to print them. When I run this code, I expect to see the sets here in the terminal, the values of the set. So the empty set is returning only this for us. So it says it's an empty set, so nothing to be shown there. And for the set of numbers that we are printing the message here, it is printing numbers variable, which is a set here declared, and its elements are 1, 2, 3, and 4, and we see them in here. And finally, here I'm having mixed data set, which is calling this mixed set, and it contains 3 elements: 1, hello, and 3.14. So in this video, we learned how to create and print elements of a set. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to add and remove elements from a set. I'm declaring a set here, and I'm initializing it to 1, 2, and 3. So there are 3 elements here being assigned to this set, and the name of my set is my set. So in order to add one element to this set, I'm having the name of my set, then the add function, and in parentheses, I type down the value that I want to be added to this set. So let me comment the rest of the code first, and afterwards we're going to investigate those as well. So now I added one element to my set, and this value 4 is added to the set. So the set is updated, and now I'm printing the message after adding 4. Then I'm printing my set. So when I run the code, I see this in the output. After adding 4, this message, and then the set is being printed. Now the set BC has 4 elements: 1, 2, 3, and 4. Previously, it had only 3 elements. So we learned that we can add elements or values to our set. So now we're going to discuss how to remove elements from a set. So our set is now having these 4 elements, and I would like to remove element 2. So number 2, I want to eliminate it from my set. I type down my set dot remove, and then I type down number 2, and then I'm printing the message saying that after removing 2 and printing out my set. So after removing 2, when we compare this set with the last version of the set, the previous version of the set, let's say, we see that number 2 is being removed here. One thing to mention here is that if the set does not have one element, and I type down the wrong element here, so I'm typing down to remove number 5, but there is no number 5 here. So it is going to give us an error. So it's a very good thing to know that if you type down the wrong number, you're going to receive an error from the compiler. There is another way to remove elements in a set. So in order to remove elements in another way, from a set, we can type down the name of our set, then use the discard function. And then in the parentheses, I'm going to type down the value or the number that I want to be removed. Then I'm showing the message after discarding 4, and then I'm printing my set here. So when I have this function discard being run, we see that after discarding 4, this message, and we're printing our set. So the previous version was containing 1, 3, and 4. So we discarded number 4 and we see only 1 and 3. So there are only 2 elements left now in the set. And one thing to mention here is that if we type down the wrong element number here in parentheses when using discard function, and when I run, it shows no error to me. So it runs, but it does nothing. Okay, so this is very important to know that. So in this video, we learned how to add or remove elements from a set. And also we learned if we are using the remove function, if we type down the wrong number in parentheses to be removed from the set, and that number is not existing in our set, it is going to return an error. We learned that we can do the same thing with discard function. We can remove elements with the discard function, but the difference is that if we are going to type down the wrong number that does not exist in our set, it is not going to return any error message for us in the terminal, so we are not able to trace it easily if we are typing down the wrong number. So this was it. In the next videos, we are going to dive deeper into the set concepts. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to check if a value is present in a set or not. So this is my set here. It has 1, 2, 3, 4, 5 elements, and the elements are from 1 to 5, in fact. And I would like to check to see if number 3 is inside this set or not. To do that, I'm having a variable called value. It is assigned to number 3. So I'm calling the isValue in set function, and I'm passing 2 arguments. First, I'm passing my value variable, and then I'm passing my set. So this function is going to check if this value variable, which is 3, is having the element in this set or not. So if this 3 number is one of the elements of this set or not, this function is going to do that for us. So this function is declared and created using the def keyword. The name is value in set, and it accepts 2 arguments, value and my set. Then it is going to return the output for us, and it is going to return this for us. It is going to check if value is in the my set. So 3 already exists in this set. So we expect the output of this return function will be true. So when I run this code, the output, it says is value in set. So this is the message, and then we're calling the function and passing the argument. So it is going to return the result for us, and the return of this is going to be true. Why? Because 3 exists in this my set element. So if I type down 5, the answer is still true, because I'm asking to see if number 5 is inside this set, and we see that number 5 is indeed there, so the answer is true. But when I have the 7, the answer is false, because 7 is not one of the elements of this set. So this is how we can check to see if a number is presented in a set or not. Thank you for watching. Hello everyone, welcome back. We would like to write a program that finds the maximum and minimum values in a set. Here is my set. It has 5 elements. The elements are 5, 1, 8, 3, and 7. So we would like to find the maximum and the minimum. So the maximum we can find easily ourselves. So it's 8, and the minimum is 1. But what if we have a set that is very large? We need to use coding to find the maximum and minimum. So in order to do that, I'm having my function called max and mean. And here is the function call. So we are calling this function, and as the argument, I'm passing my set here, okay? And when this function is called, it is using the max function. So let me type it here. And min function. It is using these two functions to find the maximum number in the set and the minimum number in the set. So basically, if I want to find the maximum number in my set, which is the name of the set here, and the minimum number of my set, which is again the name of my set here, this function, this is predefined in Python, is going to find the largest number and the smallest number in this set for us. And this function is returning two values, first the maximum and then the minimum. Then here, when I'm calling this function, it is going to return two values for me, first maximum and then minimum. This is why on the left-hand side, I'm having two variables, because this function is returning two output. It returns two values. So the first variable from the left is the maximum, because first we are returning the maximum. So this maximum output is going to be assigned to the maximum variable, and then the minimum number is going to be assigned to the minimum variable here. And then I'm typing down the print function, and I'm typing the message maximum minimum, and then I'm calling these two variables that we initialize. So when I run the code, I see maximum is 8 and minimum is 1. So this is how we can find the maximum and minimum values in a set. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about intersection. So in order to understand intersection between sets, we need to use certain functions or certain signs in Python. Let me illustrate it with an example. Here I'm having a set, and the set name is set1. It has three elements, 1, 2, and 3. And my other set is set2, and it also has three elements, 2, 3, and 4. And as you can see it here, numbers 2 and 3 are shared between these two sets. So 2 and 3 is shown in the first set and also in the second set. So how can I have a code that can give me the shared numbers between two sets? So I would like to have the expected output to be 2 and 3. This means that I would like to write a code, and that code computes the shared number, or let's say intersection, between these two sets and return me 2 and 3. We can do it in Python quite easily. We can use AND operator. So I type down the name of the first set, and using the AND operator, and then the name of my second set. And these equation here, like set1 AND operator set2, is equal to my new set. So it is a intersection set. I name it intersection set. And then I use the print function, and I type down intersection using the AND operator. And then I'm printing out my set that is called intersection set. So let me comment this part first. So when I run this code, I should be able to see numbers 2 and 3 in the output, because these are numbers that are shared between two sets. So in the output, we can see intersection using AND operator, and the output is 2 and 3. So this is one way to understand the intersection between two sets. Another way is, again, I'm initializing a variable with the same name, intersection set. And what I'm doing, instead of using the AND operator and typing down the names of the sets before and after the AND operator, I'm typing down the name of my first set, then I put a dot here, then I type down the intersection keyword. So it is going to call the intersection function for me. Okay, so I'm typing down the intersection, And then in parentheses, I type down the name of my second set. So let me review. I type down the name of the first set, dot the intersection keyword, and in parentheses, I'm typing down the name of my second set. And then I'm having this print function to print the intersection set for me in the output. And I'm showing the message intersection using intersection function or method, let's say. Then I'm typing down the name of my set that is assigned to the intersection of these two sets. So when I run the code, again, I see this message intersection using intersection function, and the output, the result of this set is 2 and 3. So this is how we can use intersection to combine the code in a way that it can give us the shared numbers between two sets. And it's quite easy. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to find common items in two lists using sets. Here I'm having two lists, list 1 and list 2. List 1 has 4 elements, 1, 2, 3, and 4. List 2 has 4 elements, 3, 4, 5, and 6. So the common elements in these two lists are 3 and 4 because these two elements are shared. So we would like to have the 3 and 4 in the output. To do that, I'm using the print function. I'm showing the message common items. Then I'm calling the common items function and I'm passing two arguments. And these two arguments are basically the two lists that we have here. So I use the def keyword to create my function. I'm having the common items as the name of the function, and these are the two arguments being separated by a comma. Basically, what we do is the following. We convert these two lists, into sets using the set function. Okay. Using the set function, we are going to convert them and we are going to use the AND operator. Why? Because AND operator is going to help us to find common elements between two sets. Okay. So AND operator is going to help us to find common elements in two sets. Okay. So I first convert these two lists to sets using the set function, and then I use the I use the AND operator to find the common elements between these two sets, and it is going to basically return the output for us. And when we call the function, it is going to do the calculation and return the output, and output is being printed in the terminal here. So 3 and 4 are the common elements between these two lists. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about symmetric difference. So let me give you the definition of symmetric difference. So the symmetric difference of two sets contains all elements that are in either of the sets but not in both. This means that the symmetric difference excludes elements that the two sets have in common. To illustrate it with an example, I have set 1. It has 3 elements, 1, 2, and 3. I have set 2. It has 3 elements as well, and the elements are 3, 4, and 5. So the common elements between these two sets is number 3. And if we exclude number 3, we can get the symmetric difference. So the symmetric difference of set 1 and set 2 equals 1, 2, 4, and 5. All elements that are in either of the sets but not in both. So this is the meaning of symmetric difference. But how do we do it using Python? To do that, we have the name of the first set, then the operator of the symmetric difference, and then the name of the second set, and this is equal to our new set, and I name it symmetric difference set. It could be X, for example. It could be Y. It's your choice. Then in the output, I'm using the print function and I'm typing down symmetric difference using, and then I type down the name of the set. So it is going to print me the symmetric difference of two sets. And there is another way to do that as well. So I type down the name of my first set dot symmetric underscore difference keyword, and in parentheses I type down the name of my second set. This is equal to my new set that I call symmetric difference set, and I print symmetric difference using symmetric difference function or method is, and then we are having the comma here and then the name of my it's newly generated set. So when I run this code, I see exactly this output: 1, 2, 4, and 5, 1, 2, 4, and 5, and 1, 2, 4, and 5. So we learned two methods by which we can compute the symmetric difference of these two sets. Thank you for watching. Hello everyone, welcome back. Today we would like to write a program that finds the second smallest number in a list, and we can do it using sets. Okay, so here is my list and it is not sorted. We would like to have the second smallest number in this list. So the smallest number is 1 and the second smallest number in this list is 2. But how do we get that? We write a function called second smallest. So I'm using the print function to show this message in the output, second smallest number colon. So this message is shown in the output and you see the result is 2. And then I'm calling the second smallest function and I'm passing my list, which is called numbers, as an argument. Then what we basically do here is the following. I have my list being converted to a set. Why do we do that? Because we would like to get rid of duplicates. In case there are some duplicates, we need to get rid of them. And then why do we need to get rid of the duplicates? Because if we have a set like this, and if we want to find the second smallest number, we are going to access this index. Okay, and this index is the smallest number and not the second smallest number. The second smallest number in this set, in this list, sorry, is number 2. But because we are having duplicates, we are getting the wrong output. So this is why we need to get rid of the duplicates. And to get rid of the duplicates, we convert it basically to a set. Automatically, duplicates are removed. Then I use the sorted function to sort everything in ascending order. And then I'm assigning it to a variable called unique numbers. Okay, so if I print unique numbers here, unique numbers, and I run the code, you see here it is sorted. Okay, and there is no numbers that is being repeated. So we got rid of the duplicates because we were having two fives, for example, there. So we got rid of the duplicates using this set, and then we sorted in ascending order. So now we are having in ascending order, and the second smallest number is basically the second number from left. And to access that, we type down the name of the variable and then we type down the index. And the index 1 is for number 2 because the first element has the index 0. And in order to access this element, we need to use index 1. So if I type down, for example, index 0, it is going to print 1 in the output for me, but 1 is the smallest number and it is not the second smallest number. The second smallest number here, as we see, is number 2, which has the index 1. So when I run, I see in the output number 2. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to do membership testing for sets. I'm having one set that is called my set. It has 3 elements, 1, 2, and 3. Then I'm printing is 2 in the set, I would like to check if number 2 exists in the set my set. Mathematically speaking, if I want to check that, I type down number 2, then I use the in keyword, and then I type down the name of my set. Okay. And also I would like to see if number 5 exists in the set or not. Here I type down the message, is 5 in the set? And if I want to do it in the programming language, I type down the number, then in keyword, then name of the set. Let's say set name. Okay. So when I run this code, the first statement is true. Why? It returns us the value true because 2 is indeed existing in my set. So number 2 in set. I'm saying, is number 2 in the set? And the answer is yes. This statement is true because 2 indeed is inside this set and it is one of its elements. And then I'm saying that is 5 in the set? And no, the answer is no. This statement is not true because 5 is not in the elements of the set. Therefore, the answer is false. But if I type down, for example, here is 5 not in the set, is this statement true or false? 5 not in my set. Okay. So what do you think? Is 5 not in the set? I'm saying, yeah, number 5 is not in the set. Yeah. And I'm typing it in Python programming language. 5 not in, and the name of the set. So the answer of this statement is true. Why? Because indeed 5 is not in my set, because it's not in my set. So we could do the membership testing either using the in keyword or not in keyword. And in order for you to have a better understanding when you're doing it, it would be nice to type down these statements in words as well. So you're typing it in mathematical language, for example, here, or in Python syntaxes. But it would be nice to type it down in words as well. It sounds nicer when you type it down, I think. So you type down is 2 in the set, and then you type down the code. And here, when you're having the question here, is 2 in the set, and you see true. Okay, so true, therefore 2 is inside it. So you can find the answer completely in the terminal when you're having the message, instead of going to say, okay, the second statement is for which print, when you're having like 200 line of codes, for example, it would be very hard to trace it. So it's nice to also have these messages in the terminal. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to iterate through a set. I'm having a set called my set. It has 3 elements, and these elements are string. So the first element is apple, the second element is banana, and the third element is cherry. To iterate over this set, I use the for loop, and I type down the for keyword. I'm having the fruit. It could be x, for example, here. This is the variable that we have to going through the all elements of our set. I'm having for all x in this set and the name of my set. So I type down the for keyword, then here the in keyword, and then after in I have the name of my set, and before in I'm having my variable. And then in the next line, for each iteration, I'm printing the value of x. So in the first iteration, x equals apple. In the second iteration, x equals banana. And in the last or third iteration, x equals cherry. So when I run this code, we see exactly the same output: apple, cherry, and banana. However, we also learned how to print the set itself in one go. So when I run this code again, I use the print function and I type down my set, and I'm having the my set being printed in the output. So if we want to print elements one by one, we can use for loop to go through it, to iterate through the set. Or if we want to print all the elements of a set in one place, we can have the print function directly and type down the name of the set in the parentheses. And in this case, the name is my set. Therefore, we are having my set being printed here in the last line. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about subset and superset. But let me give you my definition and explanation using an instance. Here I'm having set 1 and it has 3 elements, 1, 2, and 3. And we are having set 2, it has 2 elements, 1 and 2. And if I want to define subset meaning, it means that we can declare that set 2 is a subset of set 1 because all the elements of set 2 are contained in set 1. Let me repeat it. So I can say set 2 is a subset of set 1, and the reason is all the elements of set 2 are contained in set 1. Therefore, set 2 is a subset of set 1. And vice versa, we can say set 1 is a superset of set 2 for the same reason, because all the elements of set 2 are contained in set 1. So in other words, if one set is a subset of another, the second set is automatically a superset of the first one. So if we want to do this checking with Python in codes, we can have the code like this. So I type down the print function, and in the parentheses, first I type down the message. I would like to see if set 2 is a subset of set 1. To type down in codes, I type down the name of the set 2, so set 2 lower than or equal to, and then set 1. This sign represents a subset. And if I want to check the superset, so I would like to mention if set 1 is a superset of set 2, I type down the name set 1, and using the larger than or equal to sign, which is the superset sign, and on the right hand side, I'm having set 2. So for the subset, when we are checking, I type down the set 2 on the left hand side, and for the superset, I type down the set 1 on the left hand side. So when I run this code, we see this in the output. So I'm asking to see, is set 2 a subset of set 1? And the answer is true. Well, yes, the answer is yes, because all the elements of set 2 are included in set 1. And then I'm saying, is set 1 a superset of set 2? And the answer is yes, and for the same reason. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about set comprehension. So set comprehension is a concise way to create sets in Python using a single line of code. It allows us to define a set by specifying an expression and optional conditions. For example, here, I'm having my name of my set is squares that I'm creating here. And to create the set, because I want to be the set of squares for numbers from 1 to 5, I'm having x star star 2, so square of numbers. And for each x that is in the range 1 to 6, because we're writing down 1 to 6, but we are willing to have something from 1 to 5. Why we are writing down 1 to 6 then? Because the start point is inclusive, but the end point is exclusive. So if we want to go from 1 to 5, we need to type down in the range 1 to 6. Okay, so and then when this is calculated, it is assigned to squares, and then I'm printing out the squares. So when I run this code, I see the output is 1, 4, 9, 16, and 25. But why? The reason is, so x is taking value 1 to 5, 1, 2, 3, 4, 5. And then when we are computing these numbers to the power of 2, we're having 1, 4, 9, 16, and 25. So this is how we can create a set comprehension using a single line of code. We are going to do some further exercises for set comprehension, in the next videos. Thank you for watching. Hello everyone, welcome back. Here we're going to discuss another example, another coding exercise for set comprehension. So we would like to create a set of even numbers from 1 to 10. What is the definition of even number? The definition of even number is the following. So if a number is divided by 2 and the remainder of this division equals 0, it means that number is an even number. Otherwise, it is an odd number. Okay, so this is the definition of even and odd numbers. So if a number is divided by 2 and the remainder of this division equals to 0 or equals 0, it means that the number is an even number. Otherwise, it's an odd number. So using a set comprehension method to create that, I'm setting a name for my set, and I'm saying that for this is the x, and for any x that is in the range 1 to 11, again we are saying 1 to 11 because the end is exclusive, so it is going to go from 1 to 10. And if x is divided by 2 and the remainder of this division equals to 0, using the modulo sign we can compute that. Then we are going to set that number into this even numbers set, and finally I'm printing the elements of this even numbers set. So when I run this code, I see 2, 4, 6, 8, and 10. But how this set is created like that? So for the first time, x equals 1, and then x equals 2, x equals 3, x equals 4. So let me copy paste these parts. So here is the iteration. So here is the iteration. So when we are saying for each x in the range 1 to 11, it means that x is going to take values from 1 to 10. So when x equals 1, it is saying that if x is divided by 2, the remainder equals 0. No. Therefore, this number is not going to be assigned to the set. So then 2 divided by 2, the remainder equals 0. Yes. So number 2 is assigned to the set. So 3 divided by 2, the remainder equals 0. No. Then 4 divided by 2, the remainder equals 0. Yes. So 4 is going to be added to the set. 5 divided by 2 equals 0. No. So 5 is not going to be added. 6 divided by 2 equals 0. The remainder equals 0. Yes. And 7 divided by 2 equals 0. No, so it's not going to be added. 8 divided by 2 equals 0. Yes, so 8 is going to be added to the list. 9 divided by 2, the remainder equals 0. No, so 9 is not going to be added. And 10 divided by 2 equals 0. Yes, so 10 is going to be added. But one thing that we need to be careful about, for example, 10, this is the sign, the slash is the sign of division. So 10 divided by 5, the output is 2. But 10, when we're having the modulo sign 5, it is going to calculate the remainder for us, and the remainder is 0 for this division. Okay, so this is just a reminder for you. So when I compile this, we see 2, 4, 6, 8, and 10. So 2, 4, 6, 8, and 10. So for each x that is in the range 1 to 11, and if x is divided by 2 and the remainder of this division using modulo sign equals to 0, we're going to keep that x and assign it to even numbers, and then we are printing out the even numbers. So it was a very good example of set comprehension, and I think we could have now a better idea of how to create set comprehensions. We are going to have some further coding exercise with respect to set comprehension. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about another set comprehension coding exercise. So we would like to find vowels in the word T. I'm having the vowels in T set. So the name of my set is this one. I'm creating um, a set of X for each X in the T string if X is in one of these. Okay, let me illustrate it with the output. So when I run this code, I have E and A. So when X is going to iterate over all the letters of T using this for loop, okay, one time it is going to be equal to T, one time it is going to be equal to E, and one time it is going to be equal to A. So then it is going to check if the T, for example, in the first iteration that X equals T, it is going to check T if it exists in this string. So we want to see if T equals to A, E, I, O, or U, one of them. So it checks to see if T exists in one of these letters. And the answer is no, because T is not there. Then in the next iteration, it is going to equal X to E, and it is going to check if E exists in this string. And these strings, when we are going through its letters one by one, these are the letters. Does E equal to one of these letters? I would say yes, because we have one E here. So the answer is yes. And then E is stored in our set. Okay. In the next iteration, we are having X equal to A, the last letter of T, and then it is going to check and see if A exists in this string. And in this string, when I mean it is going to be equal to, if it is equal to any of the letters in this string. And the answer would be yes, because A exists there. So the answer is yes. So when I run this code, I see E and A in the output, because these are the two letters that are vowels in the T string. So in this coding exercise, to review it, in this coding exercise, we are creating a set of X for each X in T string. So it is going to iterate over the letters of T if X is in one of the letters in this string. Okay, so these are the vowel letters in English, and this is our string. So we are iterating over the letters of T and the letters of this string, okay, the vowel letters. Then we would like to check if one of the letters in T, so for example, if the T, the first letter, equals to any of the letters here. Then if the second letter of T, which is E, equals to any of the letters here. And finally, we're going to check to see if the last letter of T, which is A, equals to any of the letters in this string that contains all the letters of our vowel sound. And the answer for T is no, because we don't see T here. For the E, the answer is yes because we have one E here. And for the A, the answer is yes because we are having A as well here. So the output is E and A. So this is how we can create a set of X for each X in T if X in this string. Okay, A, E, I, O, and U. This is how we can make a comparison letters by letters between two strings. So if the first letter equals to any of the letters of the second string, the second letter of the T, which is E, exists in any of the letters of the second string, and the last letter A exists in any of the letters of my second string. So basically we are saying if T equals to any of the letters of my second string, and when I say string, I mean E, I, O, U, because we are defining it in double quotes, so it's a string. And then if E equals to any of these letters, A equals to any of these letters. So this is how we can create a set of X using set comprehension. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to create a set of vowels found in the string hello world. So here I'm typing down the name of my string vowel in word. Then I am creating a set of X for each X that is in hello world string if X is in this string A, E, I, O, U as well. So here we see that when we are having this for loop, it is going to iterate over all the letters of the hello world string and checks to see if that specific letters equals to any letters in this string, which are the vowel letters. For example, it is going to say for the first iteration, while we are iterating over this string, it is going to check and see when if equals to H, if H equals to any of the letters in this string. Okay, so it is going to check if H equals to A, H equals to E, H equals to I, H equals to O, H equals to U. Okay, so it is going to check this out. It is going to check this out, and because the answer is no, it is not going to um, store H in the created set of X. Okay, then it is going to move on to the second letters in the next iteration. So it sees that E exists in this string. So the second letter in the hello world is E. X equals to E. So it is going to check to see if E equals to A, E equals to E, E equals to I, E equals to O, and E equals to U. So it is going to check these conditions. So the answer for this one is no, 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 but for this one the answer is yes, because we are having one letter E in the second string. So it is going to mention that, okay, the second letter in the hello world string exists in this string. Okay, so it is going to get this E letter and assign it to our vowel in word set. So we're going to store this E. So it is going to iterate over all the letters of a hello world. L, L, another letter O, for example. So O is here and O exists in the second uh, string. So it is going to store O as well in our vowel in word set, but L is not here, so it's not going to store it. Again, L not here, not storing O there, so O is there, so it is going to store that. W is not here, so it's not going to store it. We are having O here, so we already stored one O, so it's not going to store duplicates. and R is not here, L is not here, and D is not here as well. So it is going to iterate over all the letters of the first string and checks to see if any of the letters of the first string equals to any of the letters in the second string. And our second string is A, E, I, O, U. And because we are iterating over the letters one by one, we are offering a string A, E, I, O, U. So H equals to A, no. E, no. I, no. O, no. U, no. Then second letter of the first string is E. E equals to A? No. E equals to E? Yes. So it is going to store E. Then the third letter of the first string, which is the hello word, it is L. So L equals A? No. L E? No. L I? No. L O? No. L U? No. So L does not exist in the second string. Therefore, it's not a vowel letter because in the second string we are only storing the vowel letter. So this is how it is going to go over all the letters in the first string and compare it with all the letters in the second string. Okay, so the first letter and first letter, second letter, third letter, and like fourth letter and fifth letter. So it is going to compare the first letter with all the letters of the second string, then the second letter with all the letters of the second string again, then the third letter of the first string with all the letters of the second string, etc. until the end. And when uh, we find a letter in the first string that exists in the second string, it is going to store it in this set. So when I run this code, I see E and O in the output. It means that this string is having E and O letters that are existing in the second string as well, and the second string are the vowel letters. So we are mentioning in the hello world string, we are having two letters that are vowel. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about frozen set. There is a function in Python that we can use to freeze the set for ourselves for any purposes. For example, in the beginning of your code, you want to initialize the set and you want to make it to be frozen to make sure there will be no modification for this set throughout your program. Okay. In order to do that, I'm just having a set name called frozen set. It could be, for example, X. I would say, let's put it X. It's easier. And then I use the frozen set function. In parentheses, I type down the elements of my set. So I'm initializing my set 1, 2, 3, and 4, and simply just using the frozen set function to do that for us. And then I'm printing my set. So when I compile, I see that my set is 1, 2, 3, and 4, and it shows the message that it is a frozen set and not a normal set, so we cannot change it. If we want to try and change it, we will receive an error from the compiler. So I'm trying now to add one element, number 5, to this set, and when I run, I see an error. Attempting to modify will raise an error. Why? Because we cannot modify a frozen set. So this is why we use frozen set function to help us to make sure throughout the program, all over the program, throughout the program, the set remains the same and remains unchanged. So this is how we can use frozen sets in our program in Python. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that finds elements that are in set 1 and not in set 2 or set 3. We are having three sets here, set 1 to set 3. Set 1 has 4 elements, 1, 2, 3, and 4. Set 2 has 4 elements, 3, 4, 5, 6. And set 3 has 4 elements as well. So 4, 5, 6, and 7. So we would like to find elements that are in set 1 and not in set 2 or in set 3. So let us start with the first element, 1. Is this number exists in set 2 or 3? No. So one of the numbers that we are looking for is 1. Then we check the second element, number 2. Is that number exists in set 2 or 3? No. So the second number that we are looking for is number 2. So the third element, the third number is number 3. And we see that number 3 exists already in set 2. So this is not what we are looking for. And the other one is number 4. And we see that number 4 already exists in set 2 and set 3. Therefore, these two numbers are not the numbers that we are looking for, 3 and 4. So the unique numbers that are in set 1 only are 1 and 2. But how can we find it using Python and not doing it manually? To do that, I'm having a set called result. Then I'm having the name of my first set, which is set 1, dot difference keyword, and in parentheses I type down the name of the second set, dot difference keyword again, so the difference function is going to be called. And then in parentheses I type down the name of my third set. And the result of this is going to be 1 and 2. So the things that are in set 1 and not in set 2 or set 3. This is how it is going to calculate it and assign it to result set, and we are printing out the set that is called result, and we see that in the output we are having the number 1 and number 2. So to review it, we type down the name of my first set, that is set 1, then dot difference, in parentheses I type down the name of the second one, dot difference, and in parentheses the name of our third set that we would like to investigate. And this code is basically going to find us the elements that exist in set 1 and do not exist in set 2 or 3. So number 1 does not exist in set 2 or 3. Number 2 does not exist in set 2 and 3. So these two numbers are the numbers they are looking for. Number 3 already exists in set 2, and number 4 already exists in set 2 and 3 as well. So we would like to find these two numbers using Python, and using Python we type down the name of the first set, dot difference, and then the name of the second set in the parentheses, then dot difference, and then the name of the third set in parentheses. Thank you for watching. Hello everyone, welcome back. In this video we would like to write a program that takes a sentence as input and prints the unique words in it. So here I'm having a string called sentence, and this string is here. So it has apple being repeated 2 times, banana being repeated 2 times, and orange. But we see that banana and apple, they are both duplicates. So they have duplicates and they're repeated because we are looking for unique words. We can think of sets because one of the features of sets is that they can help us to have the unique elements. So it does not allow duplicates. So we can try to convert them to sets. Okay. So I'm having my variable called x, which is a set, and I try to convert this string into a set, so the set automatically will eliminate the duplicates. To do that, I'm having my variable x, which is a set, and I'm trying to convert this sentence into a set. So I type down the name of the sentence, but before converting that, I use the split function here. So a split function helps me to divide the string into words based on the white space by default and return a list of those words. And this is going to be very helpful because when we are having words, word by word elements here, a set can immediately identify the repetition. So I'm going to use the split function to have this string being divided into words. So it's not going to be apple, banana, etc. It is going to be apple, banana. Sorry, there is an extra in here. Apple, orange, then banana. Okay, it is going to, so this is what the split function is going to do. It is going to divide this string into words. They're separated by a comma now. Okay, then because they are in a function called set, they are going to be converted to set. And while they are being converted, so apple is going to be assigned to my set called x because there is no duplicate for that. Banana is the second element, is going to be assigned to my variable to x, which is a set. Then another element is apple. So when we are trying to insert this apple, the Python compiler will understand that one apple already exists in the set, so it's going to just eliminate the second one. Then it goes for the orange, so it says orange, it's not there already, so we are going to insert orange. And finally, banana, it says that banana already there, so we're not going to insert another banana because it's not possible in sets. So this set X is created, and then basically we are using the print function to print our set. So apple, banana, orange, this is what we expected to have in the output. So in this video, we learned how to convert a string into a set, and also we learned how to use the split function to divide a string into words, so set can see a string word by word. Therefore it can identify the duplicates, and it is going to automatically basically eliminate the duplicates. Thank you for watching. Hello everyone, welcome back. In this video, we would like to write a program that takes two lists and prints their common elements. We learned that using AND operator in sets, we can find the common elements. So here is my list 1 and list 2. List 1 has 3 elements, 1, 2, 3. List 2 has 3 elements, 2, 3, and 4. So first of all, we need to convert them to sets. To convert them to sets, I'm having the set keyword, and in parentheses, I type down the name of the first list and then the name of the second list. And here between them, I'm having the AND operator because we learned that AND operator in sets can help us to find the common elements. So set in parentheses list 1 and set in parentheses list 2, it is assigned to another set that is called common elements, and we are printing out the common elements. So when I run, I see number 2 and 3. Why 2 and 3? Because 1 is not shared between these two, 4 is not shared between these two, so number 4 is not common. It's not a common element. Number 2 is shared, and number 3 is shared. So these two numbers are the only numbers that are common elements between these two lists. So it is going to help us to find it. So now we are having two lists that we would like to find their common elements. The first thing is to think of sets, because it was one of the features of the set that they could give us the common elements among two sets. And then after converting them to sets, we can use the AND operator to find the common elements and assign them to a new set, and then we are printing out the new set in the output. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to simulate a lottery draw by generating 6 unique random numbers between 1 and 49. To do that, I am using the random library. So I need to use the import keyword in order to have access to this library. Then I am initializing an empty set that is called lottery numbers. It is equal to set with empty parentheses. Basically, it is going to create an empty set for us. Then using the len function, I am keeping track of the size of my lottery numbers set. So this len function is going to calculate the size of my set that is called lottery numbers. Okay, so we are typing down a while loop, and as long as the length of this set is lower than 6, take this set and add random numbers. How? I take the name of the set dot and use the AND function, and in parentheses we are typing down random dot rand int. So it is going to randomly generate an integer number for us, and it is going to range from 1 to 49 here for us. Okay, and that generated number randomly is going to be using the add function and being inserted to these lottery numbers, and then it is going to go back up, measure the length of this set for us to see how many elements are there. And if the elements are lower than 6, it is going to enter the while loop one more time and generate another number. So when I run this code, I see 6 numbers are generated in our set here that are 41, 40, 41, 15, 48, 18, and 22. So if I run the code one more time, we see that the numbers will be different with these ones. So when I run this time, I'm having 6, 8, 42, 12, 46, and 25. So in this example, we learned how to use sets to generate unique numbers for a lottery draw. Thank you for watching. Hello everyone, welcome back. In this video, we would like to write a program to check if one list is a subset of another. Here are the lists that we have. List 1, it has 2 elements, 1 and 2, and list 2, it has 4 elements, 1, 2, 3, and 4. In order to know if this list 1 is a subset of list 2, for example, we can convert them to sets using set function, then use the isSubset function to check if list 1 is a subset of list 2. Okay, let me illustrate it with an example here. Now I would like to check if list 1 is a subset of list 2. Okay, so first I use the set function to convert list 1 to a set, then use the dot and isSet function is called, and in parentheses I need to type down the name of list 2, but before typing it down we need to convert it to set. So I use the set function to convert list 2 to a set as well, just like the list 1 that was converted to a set. Then all this is inside a parenthesis to call the isSubset function to check if list 1 is a subset of list 2 when they are converted to sets. Of course, we can use this function. And the result is assigned to this variable. So we expect to see a boolean in the output because it is going to be either true or false. And the result is stored in isSubset variable. And here I'm printing out the isSubset variable. So the answer is true. It means that list 1 is a subset of list 2. Why? Because all the elements of list 1 are contained in list 2. So, and this is how it works, but we can also check the superset. So I would say now list 1 is superset of list 2. The answer should be false. The answer is false. But if I change their name, so list 2 is a superset of list 1, The answer is now true. So depending on what we are looking for, we can basically convert our lists to sets and use the functions instead to perform some of these tests that are interesting. Thank you for watching. Hello everyone, welcome back. In this video, we are going to talk about set union, or we are going to talk about, let's say in other words, how to combine two sets to create a new set. Now we are having two sets here, set 1 and set 2. Set 1 is having 1, 2, 3, and set 2 is having 3, 4, and 5. So this number 3 is in set 1 and it is also in set 2. In order to combine them, I'm having x variable being declared, and I'm having set 1 pipe operator and then set 2. So this line is going to combine these two sets for us, set 1 and set 2, and here I'm showing the message union using pipe operator, and then printing out the X set for the user in the terminal. We see the output. So in the output, 1, 2, 3, 4, 5. So the sets are combined. But what happened? Here we see only 1 tree. We had 1 tree here and we had 1 tree here. Why we are not having 2 trees in the output when we are combining two sets? The reason is this. We learned in the introduction video that sets do not allow repetition and duplicate values in themselves. So this is why the set, when it is combined to form a new set, it is not taking two values that are the same. So this is why in the output we are seeing only 1 tree value, because sets do not allow duplicate values. There is another way to combine sets. The other way is like this. So we can either use pipe operator to make the union, or we can use the union function simply. We type down the name of our first set, then the union, and in parentheses, we type down the name of the second set. And this is assigned to our variable called y. Now I'm typing down the message union using union function, and I'm printing this y for myself in the output. So we see in the output the sets are having the same elements, and in this case also we are not having two number 3 being printed in the output for the reason that I mentioned. It's your choice, either using pipe operator or using the union function. Both of them can help us to create a new set based on two already sets that we are having. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to talk about set difference. We would like to understand what are the numbers that are in set 1 and not in set 2. So here I'm having two sets, set 1 and set 2. Set 1 has 3 elements, 1, 2, and 3. And set 2 has 3 elements, 2, 3, and 4. So we would like to understand what are the numbers that are in set 1 but not in set 2. After checking the numbers in set 1, we can see number 2, okay, this one is here also. So 2 is in set 1 and also in set 2. Number 3 is in set 1 and it is also in set 2. But number 1 is in set 1 and it is not in set 2. So we are looking to find the numbers that are included in set 1 and not in set 2. Okay, so we see that number is number 1. But how can we understand it using like some coding or functions in Python? To do that, it's very easy. We type down the name of the first set, and then minus or subtraction operator, and then set 2. And this is going to calculate for us the numbers that are indeed in set 1 and not in set 2. And it is assigned to a new set called difference set. So then here I'm using the print function to type down the message difference using and this minus operator or sign. And here I'm typing down the name of the difference set here. There is another way to do it as well. The other way would be to type down the name of the first set dot the difference keyword, and in parentheses we type down the name of the second set, and this is assigned to my new set that is called difference set. So, and we are typing the message saying that difference using the difference function or method, and then I type down the name of my set that I want to print its value. So when I run, I see number 1 is shown. Using both methods, we reached to number 1, showing that we did the correct calculation, because when manually we checked that, it was again number 1. So it is very important to know that this method is going to give us now the things that are included in set 1 and not in set 2. This is why the set 1 is first and then the set 2. Set 1 is first and then the set 2. If we want to understand the numbers that are in set 2 and not in set 1, we need to change the place of set 2 and set 1 in these equations. And these are two ways to find the difference between these two sets. And as you decide, it's your choice. You can go ahead and choose which one, whatever that you're comfortable with. And the other thing that I would like to mention here is that, for example, if I add one number here, for example, and when I run, we see that number 10 is now written here. Why? Because now I added a new value to my first set, and this value is not in set 2. So this is why I can see 1 and 10. So if I include 10 also here, and I recompile, I should not see 10 anymore here. So when I recompile, yes, we can see that only number 1 is there. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to get unique values from a list using sets. Okay, so this is my list. It has 1, 2, 2, 3, 4, 4, 5. These are the elements of this list. And there are duplicates. You see there are 2 number 2s and 2 number 4s there, okay? We would like to remove duplicates, and we would like to have only unique values. So this is the expected output for us. 1, 2, 3, 4, 5, okay? So the duplicates must be removed. And because we want to do this, I type down the print function. I type down the message unique values colon, then I call the unique values function, and I'm passing the list as the argument. I use the def keyword in order to initialize and create my function. This function is going to basically convert this list to a set. And one of the features of sets is that they do not allow duplicates. So when we convert the list into a set, automatically duplicates are removed. Therefore, when I run this code, I see that I'm having a set of unique values. Okay, so this is how we can easily get rid of the duplicates. But if we want to also have list in the output, for example, here you see that we are having a set in the output, but if we want to have a list in the output, we can use the list function. So I'm first converting my list to a set, and everything is okay. So we saw the output, duplicates are removed. So that's the end of the program. But if it is obligatory to have a list as the output, we can further convert the created set to another list again using the list function. So basically, first I use the set function and type down the name of my list. So this list is being converted to a set, and it is automatically getting rid of the duplicates. So this is the end of the program if we are okay to have an output with a set. Okay, but if this is, for example, a force that we are looking for a list in the output, we can use the list function by typing down the keyword list and put everything in the parentheses. Therefore, it is going to convert the created set, which already got rid of the duplicates, to another list. So when I run the code, I see that I'm having a list here, and we got rid of the duplicates. Thank you for watching.